Okay, this is the third and final video on trigonometric integrals. So here we're going to be specifically looking at integrals involving tangent and secant, or maybe one just involving tangent. In the previous video, we looked at integrating secant cubed, and so that was a little bit different than how we're going to integrate some of these things. So here we're going to be looking at integrating tangent to the fourth x, secant to the sixth x dx. And so the idea here is to either save a secant squared. So if you save a secant squared, you want to convert everything else to tangent. So because then you would say u is tangent, du would be secant squared dx. Or you want to save a secant tangent and convert everything to secant, because the derivative of secant is secant tangent. Okay. All right. So to manipulate this, you're going to be using the identity 1 plus tangent squared x is equal to secant squared x. Okay, so let's go ahead and try that out. So tangent to the fourth x, and then secant to the fourth x, and then secant squared x dx. So what we're going to do is we're going to save this secant squared here, the secant squared x dx, and that's going to be our differential du. Okay, so we're going to convert everything to tangent. So we're going to work on converting that secant to the fourth. So we can write the secant to the fourth as secant squared squared. Okay, and then times secant squared x dx. So we have tangent to the fourth x. Secant squared is 1 plus tangent squared, quantity squared, and secant squared x dx. All right, so we've converted everything to tangents, and we have a secant squared left over for our differential, so this is perfect. So u is tangent of x, du is secant squared x dx, and so we got a nice clean substitution. So this is going to be u to the fourth plus 1 plus u squared squared du. So when we FOIL that out, you're going to have the u to the fourth times u to the fourth, which is u to the eighth, plus u to the fourth times 2u squared, so 2u to the sixth, and u to the fourth times 1 is u to the fourth du. So it's going to be 1/9 u to the ninth plus 2/7 u to the seventh plus 1/5 u to the fifth, and then plus constant of integration. So it's going to be 1/9 tangent to the 9th x plus 2/7 tangent to the 7th x plus 1/5 tangent to the 5th x, and then plus constant of integration. And we can go ahead and verify that this is in fact the correct antiderivative by taking the derivative and seeing that we do get the original integrand. Okay, so write that all in there, and we'll go ahead and take that derivative. Okay, so it's going to give us tangent to the 8th x, and then a secant squared by the chain rule, plus a 2 tangent to the 6th x, and then a secant squared by the chain rule, plus tangent to the 4th x and a secant squared by the chain rule. C goes away. We have a tangent to the 4th x and a secant squared x in common, so we're going to factor that out, and we're left with tangent to the 4th x plus 2 tangent squared x plus 1. Okay, so that's going to be tangent to the 4th x, secant squared x, and then the other part factors into tangent squared x plus 1, quantity squared. Tangent squared plus 1, if you recall, was secant squared. So that becomes secant squared squared. So we have tangent to the 4th x, and then secant to the 6th, because you have secant squared times secant squared squared, so that's going to be secant squared times secant to the 4th. So we get secant to the 6th. Okay, so we have verified that this is in fact the correct antiderivative. Okay, I think I got 3 more, and that'll be it for this section. So let's go ahead and look at another one. So we're going to look at integrating the tangent cubed times the secant cubed dx. Okay, and so the goal here is to save either a secant x tangent x and convert everything into secant, or save a secant squared and convert everything to tangent. Probably be easier to save a secant tangent, but let's see what happens. All right, so we got tangent squared x, and then secant squared x. And so we saved a secant x tangent x, okay? And so if we're going to save a secant tangent, we want to convert everything to secant because the derivative of secant is secant tangent. Okay, this looks good. All right, so tangent squared x plus 1 is equal to secant squared, so tangent squared is equal to secant squared x minus 1. Okay, so we're going to replace that tangent squared with the secant squared x minus 1. Okay, then we got a secant squared, and then the secant x tangent x dx for the differential. Okay, this is perfect. U is secant of x. Du is equal to secant x tangent x dx. So this becomes u squared minus 1 times u squared du. So that's going to be u to the 4th minus u squared du, which is going to be 1/5 u to the 5th minus 1/3 u to the 3rd plus constant of integration. So 1/5 secant to the 5th x minus 1/3 secant to the 3rd x plus constant of integration. All right, and so there's our antiderivative. If we want to verify that that is the correct antiderivative, we'll go ahead and take the derivative of it. It's going to take the derivative here. And so that's going to be secant to the 4th x, and then chain rule, secant x tangent x, minus secant squared x, chain rule, secant x tangent x. Okay, we're going to factor out a secant squared and a secant x tangent x. Left over is a secant squared x minus 1. All right, so now we have secant cubed x tangent x, and secant squared minus 1 is tangent squared. And so we arrive at the original integrand of tangent cubed secant cubed. Okay. Alrighty, 2 more to go. The integral of tangent cubed x dx. Okay, so this one is only tangent here. In the previous video, we looked at integrating just secant cubed. And so this is actually going to work out nicer because the derivative of tangent is secant squared. So we can pull off a tangent squared, convert it into a secant squared, and we'll be good to go. We'll have to recall the antiderivative of tangent. That is a calculus 1 integral, and that can be found using simple u substitution. All right, so we're going to go ahead and pull off a tangent squared here. And then we'll use our identity that the tangent squared is equal to secant squared x minus 1. And then we'll go ahead and distribute and turn this into 2 integrals. So tangent x secant squared x dx minus the integral of tangent x dx. The integral of tangent, if you recall from calculus 1, is the natural log of the absolute value of secant x plus c. Okay. For our first integral, the integral of tangent x secant squared, let u be tangent of x, so then du is secant squared x dx. Okay, so we'll go ahead and have the integral of u du, which is u squared over 2, so that would be 1/2 tangent squared x. Minus, and in the second integral, the integral of tangent is going to be minus natural log absolute value of secant x plus c. Okay. All right, and we'll go ahead and verify that that is, in fact, the correct derivative. So derivative 1/2 tangent squared minus the natural log of the absolute value of secant. The derivative of the natural log of the absolute value of u from calculus 1 was u prime over u. Okay, so this is going to be tangent of x times the secant squared x by the chain rule, minus, and then u prime, so u is secant of x. Derivative of that, or u prime, would be secant x tangent x, all over u, which is the secant of x. Okay, so that's going to be tangent of x, and then what I went ahead and did was factored the tangent of x out, so there's a secant squared x left over. And then from the second term, the secants absorb, and we factor the tangent out, so we're just left with the 1. And secant squared x minus 1 is tangent squared x. And so there we are, we have our tangent cubed x. Okay, and that verifies that. Okay, we got one more to look at here, so this is going to be the last example here. Okay, one more. And we're going to look at the integral of tangent cubed x secant x, okay? And so probably what we want to do is pull off a tangent so that we have tangent secant. We still have the tangent squared, so it'd be tangent squared, tangent secant. Convert the tangent into secants and derive the secant and secant tangent, which would have, and then we'd have a secant tan left over, and we know what the antiderivative of that is. Okay, so let's go ahead and do that. So this is going to be tangent of x. Oh, sorry, tangent squared. And then, okay, so we wrote it this way. Okay, so tangent squared, secant x, tangent x, dx. Okay, so it's all there. It's all there. Tangent squared x is equal to secant squared x minus 1. All right, so we have secant squared x minus 1 times the secant x tangent x dx. We'll split that up into two integrals. So the integral of secant squared x times the secant x tangent x dx, and that's ready to go, minus the integral of secant x tangent x dx. Okay, for the first integral, u is secant, du is secant x tangent x dx. And so that is just going to be the integral of u squared du, which would be u cubed over 3. Go ahead and replace the u with secant, so secant cubed over 3. Okay, recall from Calculus 1, the integral of secant x tangent x is going to be secant x plus constant of integration. So the second integral will be secant x and then plus c. And then we'll go ahead and verify that this, in fact, is the correct derivative. Antiderivative by taking the derivative. So we're going to have secant squared x and then times a secant x tangent x by the chain rule, minus a secant x tangent x. Factor out a secant x tangent x, and then we'll have secant squared x minus 1. Secant squared x minus 1 is tangent squared, so we have secant x tangent x times tangent squared x, and so that's going to be tangent cubed x times the secant x, which was our original integrand. Okay. Well, I hope you found all these videos helpful, and stay tuned for the trig substitution in the next set of videos. So we'll see you next time.